Hi, I'm Adam. Welcome back to Godot Game Lab. In this video, we'll implement status effects in the game, while also make some cards exhaustible. So let's see how that works. If we go to a battle, you can see that I draw my card here which says at the start of your turn, gain 2 muscle. And both this one and muscle itself are status effects. So let's see how it works. If I play this card, you'll notice that a little icon appears here. Now, we have no tooltip explaining us what it does yet, but this will be implemented in a later video. And what you can also see is when we play that power card, our discard pile remained at 0, right? So you can see that it works just like in StatusUI. When we play power cards, you can't play them again during a battle because that would make them too OP. So if you take a look at the draw pile, we have 8 cards here. We have 3 cards in our hands, totaling in 11. But you can see that our deck still consists of 12 cards and the card is still there. We just cannot play it again during the same battle. So if I end my turn here, the bets do their thing and you can see that this muscle icon appears here with 2 stacks. And what this means, if you take a look at the output window, that I should do +2 damage. In reality, it won't work right now because we need a modifier system for this, which is the topic of the next video actually. But the status system itself works perfectly fine. So if I play the other one, this will deal 4 damage and apply 2 exposed to the enemy. So if I play it, I'll see that it takes 4 damage, even though it should take 6. But again, this is not yet implemented. And it has this exposed status which lasts for 2 turns. So what happens now if I end my turn, this should mean that it will take 50% more damage from attacks. But since we cannot implement this yet, instead what it does is at the start of the turn, this bat will lose 12 HP. So if I end my turn here, the duration was decreased by 1 and the bat then took 12 damage. And you can also see that the muscle is a stackable status effect because this little potion here means that I get 2 new muscle stacks at the start of each turn. So if I were to defend and end my turn here, then I have 6, right? And this should equal to +6 damage on my attacks. Another thing is that the blue card I played is not in my draw or discard pile anymore either. And again, if you count the cards here, we have 4 in the discard pile, 4 in our hand, and 2 in the draw pile, resulting in 10 cards total. Again, our deck is still 12 cards though. It just means that this was an exhausting card, which means when we play it, it cannot be played then again, right? During the same combat. So powers always exhaust by default, just like they do in StatusUI, but for all other cards, we can set this with an export variable in the inspector. So let's get started. Before we jump into the architecture overview, let's take a look at how status effects work in StatusUI. So they are called debuffs, but that's kind of the same thing. So you can see that we have like a neat table here showing us what different status effects can appear on both the enemies and the player in the game. So let's take a look at some of them. So for example, if you have a frail status effect or debuff, you see that all the block gain from cards is reduced by 25%, right? And you can see that it stacks based on duration because that number doesn't change, right? It will be always reduced by 25%. So if you start stacking the frail effect, then you actually stack the duration of the effect because it expires after X turns, right? So if you apply 4 frail, then that status effect will be there for 4 turns. Each turn that counter decrements by 1, and when it expires, then you no longer gain reduced block. So stacking it means actually extending that duration, right? However, in the case of poison, for example, you stack both of them because you take X amount of damage based on the stack of the poison, but it also remains there for X amount of turns. So it stacks both in terms of intensity and duration. And we also have other statuses which don't stack. So for example, if you have the confused debuff, then the cost of your cards will be randomized, right? And this doesn't stack. So as long as you have the debuff, it stays there indefinitely, right? Forever, basically, if you can't clear it somehow. So from the one side, we have to take this into consideration, right? We have different kind of stackabilities, so to say. And the other thing is actually applying those status effects, right? Because if you take a look at the poison, for example, you lose the HP at the beginning of the turn. Whereas with Shackled, at the end of the turn, you regain X strength, right? So one of these effects is applied at the end of someone's turn, but the other one is applied at the beginning. So again, we need to differentiate between different types of statuses based on when they are applied. And if you think about the confused status we were talking about, when will be the effect of this confused status will be applied? Well, neither specifically at the beginning of your turn or at the end of your turn, but it's more related to an event, right? So when you draw a card or you draw your whole hand, we emit a signal in the game. And that status effect actually needs to connect to that specific signal so we can randomize the cost of all the cards in the current hand. So when we implement the status effect system, if we want to be as flexible as these are in Spire, we have to take stacking into consideration and also this sort of type based on when the status effect will be applied. Architecture overview is super important in this episode because we'll be making drastic changes to the whole architecture of the game. So before we jump into the new things, let's recap how everything works now in terms of the flow of the battle. So when we go into a battle, we start by doing a player turn, right? And then when we press the end turn button, we discard all the remaining cards in the player's hand. And when the whole hand is discarded, the first enemy starts to take action. And we repeat the same process to all the enemies. And when all enemies are done, then we sort of close this loop and start the next player turn. Pretty simple, right? But when we take statuses into consideration, things will be a bit more complicated. So let's see how the new thing will look like. Again, when we go into a battle, the first thing we do is sort of connected to the player, right? But instead of starting with the player's turn, first we need to apply all the statuses which are connected to the player and should be applied at the start of the turn. And when we're done with that, the player can actually do their turn. And when they press the end turn button, we have to apply all the end of turn status effects on the player as well, right? For example, taking poison damage in Spire is performed at the end of the turn instead of the start of the turn. So that's an interesting distinction, and we need to make sure that we have the flexibility to differentiate between start of turn and end of turn status effects. And when we applied all the end of turn status effects, then we can discard the hand of the player, the remaining cards, and when they are discarded, we have to do the same thing for the enemies. So we loop through all the enemies and apply start of turn status effects, which should be applied to them instead of the player. And when a start of turn status effect is applied, then that enemy can take their action. We can apply the end of turn status effects. And when all enemies are done, we can loop back to the same cycle and apply the start of turn status effects to the player again. Right, so this is a pretty big change, which we actually need to implement in the PlayerHandler and the EnemyHandler nodes. But with the new status system comes a new resource called status. So this describes one status effect in the game, and it has a bunch of different attributes. All status effects have ID, type, they have a duration and a Boolean checkbox indicating if they can expire or not. We also have the stacks applied and the stacking type, and more on the visual side, we have an icon and a tooltip connected to them as well. So how do we use this resource, this new status resource? This resource is used by two different nodes or scenes. One of them is called StatusUI, which, you guessed it, is responsible for actually displaying the status effects below the player or the enemy. And we also have a StatusHandler, which is more like a logical being, right? It's not a visual thing, but it's handling all the logic we need to apply when stacking statuses or making sure that their duration changes over time and things like that. And the StatusHandler will be used by the player and the enemy scenes. So both the player and all of the different enemies will have a StatusHandler attached to them. And also the StatusHandler is actually a grid container, and it will be used not just to handle the logic, but to actually instantiate StatusUI scenes, so the statuses can be displayed under the player or the enemies. But if you remember, the player and the enemy scenes are more visual, right? They are not handling any logic related to turns and things like that. So we have to take the player handler and the enemy handler into consideration as well, because as we saw with the turn logic, we need to sort of reconstruct the whole thing. And that's it for the architecture changes. Let's see how we can do this. And before we jump into implementing the status system in the game, I wanted to talk a bit about bugs. I'm super happy because you keep reporting very niche and kind of hard to spot bugs in the project, and I can keep squashing them to make the project even better. This is a good thing, but I noticed that I've kind of started allocating a lot more time than I wanted to bug fixing, which kind of hinders the amount of progress I can make with the actual new content videos. So for this reason, I've decided to collect all the bugs and issues we currently have in the project. And when we're finished with all the content we have in the game in Season 2, then I will dedicate an extra video to squashing all those bugs instead of doing them sort of one by one at the beginning of each video. So if you take a look at the GitHub page we have for the project, I've opened some issues for all the bugs we have. So when you start following along with the tutorial and you encounter one of these bugs, you can check the project's page to see if we already talked about this bug, and you don't need to worry about that for now. You can sure try to fix it yourself because I think it's good exercise, but don't worry about it if you can't. Because again, we'll go back to these issues when we're finished with the whole project, and we can smooth it out with squashing all those bugs we encountered along the journey. If, however, you can find out about a bug which is not listed here in the issues, then make sure to drop a comment down below so I can add it to the list of the issues and we can fix as many of them at the end of this season. So without further ado, let's see how we can do statuses. And the first thing we need to do is to create a new custom resource for all the statuses. This is the first step, so we can create the containing data, and then we can start working on the data in different places. So with the project open, go to the File System tab, expand our custom resources folder, right click on it, and create a new script. We'll call this script status.gd and make sure that it inherits not from the node class, but from the resource class. For the template, I use object empty to make sure that we don't have any auto-generated code. Click on create, and we can scroll down and double click on status.gd to open it up in the script editor. As per usual for resource classes, the code will be pretty simple. First of all, we'll provide a custom class name called status. Then we have two different signals. One is called status applied and one is called status changed. So status applied will be used to make sure that we can notify everyone who's interested when a status effect actually finished its application. So this is important because, for example, for the status handler, when you have a poison effect on yourself and a regeneration healing effect, for example, you have to loop through all the statuses one by one and apply them, right? So this signal will indicate that this specific status finished its thing. On the other hand, the status changed signal is emitted when something about the status itself changes, and two things can change, basically. One of them is the duration and the other one is the number of stacks we have. So what about the attributes? Before we do the attributes, we need to create two enums, one for the type of that specific status, and as we discussed with the Spire debuffs, we can use three different kinds of statuses, one which is applied at the start of the turn, one which is at the end of the turn, and another one which is really special and it relies on an event happening. For example, drawing all the cards in your hand or an enemy dying or something like that. We also have another enum for stack type, which can be three different ones. In this case, a non-stackable type, an intensity-based stacking, and a duration-based stacking. If you want to, you can do a fourth one for both, like how the poison works in Spire, but for this project, I've settled with three. I think you can do a couple of cool stuff with those three as well. Okay, so what about the attributes then? We have one export group called status data, so all the logic or all the status related data will be in one group and all the visual stuff will be in another one. So as we talked about it, we'll have a bunch of different attributes. We have an ID, we have a type, which is the type enum we use. We also have a stack type for the other enum. And we have a Boolean checkbox for expiration. So the status effect can either expire or not. So setting this to false basically means that we don't really care about duration because this is an infinite effect, so to speak. And then we have two integers, one for the duration and one for the stacks. Both of those will have a setter function, so we can emit the status changed signal when they change. Then we have the other export group called status visuals. And here we have two attributes, one for the icon, which will be a texture, and the multi-line string for the tooltip. This is kind of just a placeholder for now because we'll be handling tooltips in a future video, but we can sort of have that attribute in place so it will be easier to just extend the functionality later on. In terms of functions, this is a base class, right? So we'll have a bunch of custom code, just like we do with cards, for example. So we'll need two functions for statuses. One is called initialize status, which will be sort of like the ready function in Godot, right? This will be called once when we add a new status effect to a player or an enemy. And this is useful when we have event-based statuses, for example, because you want to connect to the event bus, right? To make sure that the status does its thing when a specific event happens. So we can do this in the future in the initialize status function. And we also have the apply status function, which is sort of like the main thing for statuses. So for example, if you have a poison effect, when you call the apply status at the start of the turn, this is where you want to code losing HP or taking damage or something like that. It's similar to when we play the cards, right? We have a function dedicated to that logic, and the same thing applies to status effects as well. And this is the method called apply status. Then we have a get tooltip function, which just returns the tooltip property as a string for now. We'll worry about this later. And then we have the two setter functions, the first of which is the set duration. And here we just set the new value and emit the status changed signal. So the StatusUI, for example, will know to update the number indicator at the corner. Similar fashion, we have a set stacks function, which does virtually the same. Sets the stacks property and then emits that signal to make sure that we can notify whoever cares about this, right? And that's it really. For that new resource, we can save this with Ctrl S and actually create some statuses now. So let's go back to 2D view. And if we go to the file system tab again, we can collapse this custom resources folder. And I think we can create a new folder for status effects for the future. So we can right click on the root folder, create a new folder and call this something like statuses. And we can click on that new folder to select it, right click, create a new resource and search for status.gd. So we'll create 3 new statuses. The first one will be called exposed, and this will be similar to vulnerable in StatusSpire. So let's save this. And you can see that this little arrow appeared here. So we can expand this folder and we can see that we have this exposed resource here. Before we edit it, I think we can repeat this and add the 2 new other ones. So right click, create a new resource. This will be a status 2. Let's call this muscle, and this will be similar to strength in StatusSpire. Save this and repeat it one more time and call this true strength form. And this status will be applied when you play the power card, right? So let's edit them one by one. Double click on the exposed resource and you can see that we have our 2 groups here. We can expand both of those. For the ID, we can use exposed. This will be applied at the start of the turn. Perfect. And it will be stacking based on duration, right? Like vulnerable does in StatusSpire. And this can expire because we stack the duration. And by default, it will have a duration of 1 turn. For the icon, we can load something from the art folder. I use this cross icon here. And for the tooltip, we can just type in something like to do. And again, we'll do this in the next video. Okay, so exposed is done. Let's go ahead and change muscle.tres. So double click on this, expand both of the groups. For the ID, we can use muscle. And this will be actually an event-based status. For the stack type, we can use intensity here, right? Because it's similar to strength in StatusSpire. So the more we have, the more damage we do, right? So this can't really expire, and we can set the default stacks to something like 1 or 2. Doesn't really matter though, because we can change this value whenever we want to apply strength. Okay, for the icon, we can again load something from the art folder. I have this muscle.png here. And the tooltip, we can again leave it empty or type in something like to do. And finally, we have the true strength form. Double click on this to edit it and expand both of these groups. For the ID, we can type in the same thing, true strength form. It will be applied at the start of the turn. It won't be stacking and it cannot expire. So we can leave all of these the same. And for the icon, we can load something. I just used this little red potion here. Again, the tooltip is something we can do later on. Right, so why do we have these values here? Well, because this is a power card we'll be using and it's similar to demon form in Spire. So what the status will do is at the start of your turn, you will gain 2 muscle every turn, right? And this is an infinite kind of buff you can have, so it won't expire and it won't stack either. Right, so we have our 3 statuses ready to go. We can save this with Control S. And now we can start building stuff around this resource we have, the status resource. So probably the easiest one and the first one we should do is the status UI, which is used to visually display to the player these status effects. So click on this plus sign to create a new scene, and we'll use a user interface node, a control node as a root node, and we can double click and rename this to StatusUI. You can zoom in because it will be much smaller, and we'll add 3 child nodes to this StatusUI root node. So click on the plus sign or press Ctrl A. First, we'll add a texture rect for the icon. Then we can select the root node again and add the label node for the duration, and we can sort of duplicate this because we'll have a different label for the stacks. So let's rename these. So double click on the texture rect, rename this to icon. The label we can rename to duration, and the other one we can rename to stacks. Let's select the icon next, and we can load something to see how this will look like. Maybe we can load this heart icon here, and we can change the properties for the texture rect because this will be way too big. So let's set this to ignore size and keep aspect centered. And under layout and transform, instead of 40 by 40, we can reset this and set the minimum size to 10 by 10. 10 pixels is more than enough for one status effect. And the root itself, you can see that it's covering the whole screen, which is pretty bad, especially because this will be clickable later on, right? Because we want to display the tooltips. So it's not a good idea for this to cover up the whole screen. So for now, we can just set the anchor preset to the top left. And you can see that it shrinks to 0, but it doesn't really matter because we'll set this from code later on, and I'll explain why in a second. So next we can select the duration label, and we can type in something like 99 because I think that's probably the most amount of text we can have here. Set the horizontal and vertical alignments to center, and we can make this label much smaller, right? It doesn't need to be this big. So under layout and transform, we can click on this arrow to reset it like so. Cool. Now we just need to move this to its place. So I press W to go into move mode and sort of drag this around to my liking. Yeah, that looks kind of nice. I go back to select mode by pressing Q, and we can see how it looks like with 1 digit. I think that's fine. It even works for 3 numbers. Yeah, I think that's perfect. And we kind of want to do the same thing for stacks. A wiser thing to do would have been waiting with this second label and only duplicate it now when we are finished with all the properties we wanted to change. But it's fast, we can do this again. So type in 99, set it to the center, go to layout, transform and reset the size. Go into move mode and pressing W and make sure that they laid on top of each other perfectly. So I opted for 2 label nodes here, and we can display whichever we want to display based on the stacking type. So if it stacks based on duration, we can hide this one. And if it stacks based on intensity, we can hide this one, right? And if it doesn't stack either way, like the power status, then we can hide both of them, right? And we'll do this from code. So basically that's all the setup we need for that scene, but we haven't saved it yet. So press Ctrl S to save this. And we can go into our scenes folder, which is not here. So I can go up one level, scenes. And I think we can create a new one for the status handler, and we can put this scene under there too. So click on create folder, call it status handler, and we can save this as StatusUI.tscn. Perfect. Now we just need to set up all the things we need to in the script, actually hiding those labels based on the type, displaying the icon, and also setting the size of this control node to make sure that when we implement tooltips, it will be as big as it needs to be. So why do we do this dynamically? Well, because we don't know how wide this label is going to be, right? Because it can have 1 digit, 2 digits, or 3 digits as well. And based on the width of the duration and stacks labels, we need to make sure that we expand this to cover the whole thing. We can also do this with a container, by the way, but I think we might as well want to see, or I wanted to demonstrate how we can do UI stuff in code too, just to practice this technique as well. So click on the root node, the StatusUI node, and attach a new script to it. StatusUI.gd is perfect. Empty template is perfect. Click on create. And let's see how we can do this. Okay, so first things first, we need a custom class name called StatusUI. Then we'll have one export variable for the status resource, and we also need to apply a setter function to this, because whenever we change the status, we want to display with the StatusUI, we want to do a bunch of stuff. Then we have 3 already variable references to the icon texture rect and the 2 labels. Then we'll have this setter function for setting the new status effect. And first of all, we'll provide a safety check to see if the node is ready in the scene tree or not. And if not, we wait for it. Again, this is because with export variables, the setter can actually be called before the node is ready in the scene tree. And if the node is ready, then we can change a bunch of properties. First of all, we'll set the status to the new status we have. Then we change the icon texture rect's texture property based on the status's icon. And then we need to decide which label will be visible, if any of them will be. And this we can decide based on the status's stack type. Then we set the custom minimum size. Remember, I said that we need to handle this control node size from code, and by default we set it to the same as the icon size, which is 10 pixels by 10 pixels. But then we check if the duration is visible or not, because if it is visible, then we need to expand the size a bit, because the label will sort of make the enclosing rectangle a bit bigger, right, compared to just the icon's size. And then in an elif statement we do the same for stacks, because one of them might be visible, right? Then after setting the proper custom minimum size, we need to check if that status changed signal is connected to our callback method or not. And if it's not connected yet, then we connect it to our callback method called onStatusChanged. And finally, we actually need to call this to make sure to update all the information when we change the resource to a new status. So how is that callback function going to look like? Well, if we don't have any valid status resource connected to this UI node, then we can return from the function immediately. But if we do, we need to provide some checks when the status changes, because if it can expire and the duration became less than or equal to 0 based on the latest change, then we can queue free the whole thing because the status expired, right? And we do kind of the same when the stack type is stacking based on intensity and the stacks reached 0. Why not less than or equal to 0 in this case, right? Because we use that with the duration. Well, because if you think about strength, for example, in Spire, you can have negative strength based on debuffs, right? But you can also have positive strength. So when something stacks based on intensity, it can happen that it becomes negative. However, this might not be what you want in your game. Again, you can kind of decide how you want to handle this in your game. You can even make it more flexible if you want to by adding a checkbox to the status resource to allow negative or not, right? Because if you think about Spire, strength can be negative. but I don't think poison can be, right? So if you use one kind of question here, like I did, to make sure that I only delete it if it is 0, then you can only use one solution, right? So if you want it to be more flexible, you can expand on this system. But again, for the sake of simplicity, I just checked for 0 here, assuming that all intensity stack type statuses can be negative as well. Then the final thing we need to do when a status is changed is to actually update the two labels texts, right? Because either their stack number or their duration number has changed, right? So that's all we need to do here. We can save this with Control S, but it's kind of hard to test if it works or not right now. So we'll do some testing code in a second to see how we can see if this works or not. Okay, so to test this, first of all, let's change the code a bit and override the ready callback. And what we do is we wait 2 seconds, and after 2 seconds, we decrease the duration by 1 and the number of stacks by 2, for example. But these are arbitrary numbers. You can use whatever you like. Then we can save this with Control S and go back to 2D view. And you can see that for our root node, the StatusUI node, we now have an export variable for the status effect. And we can test all of them because they kind of work differently from each other. So let's click on this empty and quick load one of those. Let's start with the exposed, which is a duration based one. Then we can run the scene with F6 or clicking on this button. And you can see that we have 1 here. And after 2 seconds, it quickly becomes 0. And then the whole scene is deleted, which is perfectly fine because it reached 0. Awesome. So we can change this by quick loading another one. Let's test the muscle next, which is an intensity-based stacking type. We have 2 by default. And after 2 seconds, because we subtracted 2, it becomes 0 and deletes itself too. Perfect. And finally, we can quick load the last one, which is from the power one, right? The true strength form. And in this case, you can see that when we run the game, there's no label displayed, right? Because this is not stackable and it cannot expire either. So we don't have to display any of the labels. And you can see that the 2 seconds definitely elapsed now. And it's still visible, right? Because changing the duration or the intensity of it doesn't really do anything. Perfect. So everything's working as we intended them to. So we're done with the StatusUI and we can move on to the next one, which is the StatusHandler. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. So again, we need to create a new scene. So click on the plus sign here. And this time we'll be using another node. And for the statuses, we'll use a grid container to display them. So search for grid container and we can zoom in to see what's going on here and rename this by double clicking on it and calling it StatusHandler. And also we need to change one property for the grid container, which is the number of columns. For this one, I've used 6. I think it's a pretty cool number here, but we'll see how it looks in a sec. So we have our grid container right here. We can sort of reset the transform to make sure it's sitting there empty on the top left corner. And we can see how this looks like by instantiating a couple of StatusUIs, right? Because if you remember, I said in the architecture overview that the StatusHandler will handle all the logic and will actually instantiate StatusUI scenes, which we just did earlier. So if we click on the instantiate child scene button and add some StatusUIs, we can see how this looks like. You can select this and press Ctrl D to duplicate it a couple of times. And you can see that it's pretty messed up, right? And the reason why is because these are all, if we go under layout, these are all 0 by 0. Because we said that we set the custom minimum size from code. So if we were to actually run this, it would look a lot better. But for now, just to see how it looks like, it's much easier to actually select all of them by selecting the first one, then pressing and holding Shift, clicking on the last one. We can just set a custom minimum size to something like 15 by, I don't know, 16. Now that's a bit big. We can see that it doesn't need to be this big, so maybe 13. Yeah. So this is how it looks like. If you don't like that much gap between them, then we can go under theme overrides and constants and set the separation to something else. You can see that by checking both of these and setting the separation to 0 makes it a bit more packed. And I kind of like it this way, so I'll leave it at that. And if you're happy with the looks, then we can delete all these scenes because we'll actually add them from code, right? We need to keep handling all the different statuses for the player and all the enemies. So this was just to see how it looks like visually. And if you're satisfied, we can delete these nodes like so. So the status handler itself is configured, and we can save this scene because it's still unsaved with Ctrl S. And the status handler folder is perfectly fine. We can save it as statushandler.tscn. And obviously the interesting part is actually coding the logic. So let's attach a new script to this. StatusHandler.gd is fine, but instead of no default, we can use object empty to make sure that we don't have any auto-generated stuff. Right, press create and see how we can code this. To make sure that it's not too overwhelming, we'll code this status handler in 2 parts. The first part will be more like a sort of preparation for handling the logic of actually applying the statuses. So for this one, we'll create a custom class name called StatusHandler. Then we'll have a constant which loads that StatusUI scene, so we can instantiate it whenever a new status is added to this StatusHandler. Then we'll have an export variable, which is called StatusOwner, and this one ensures that we can reuse this same StatusHandler by instantiating it as a child under both the player scene and the enemy scene, right? Because both of those can have statuses and we want it to be reusable. So we have an export variable reference to the owner. So when we apply the statuses, we have a reference to whoever we want to apply those statuses to. Then we'll have a method called addStatus, which is a bit more of a complicated one. So let's see how we can add the new status. We have one parameter, the status resource, which we want to add. So first of all, we'll decide if this is a stackable or a non-stackable status. Basically, it's stackable if the stack type is not equal to none. It doesn't really matter if it's stackable based on duration or intensity. Both of those are considered to be stackable. Then we need to check if we already have this status or not. The easiest case is when we actually don't have that status yet, because then we can add it no matter what type it is, what kind of stacking it does, right? If we don't have it, then we need to add it anyway. So what we do in this case is we instantiate a new status UI scene. We add it as a child, set its status export variable to the status we have. Then we connect the status applied signal to our own callback function called onStatusApplied, which we are yet to implement. And then we call the initialize status method on that status resource, because if you remember, we said that it's sort of like the ready callback, right, for nodes in Godot. So we'll provide that one-time initialization method to make sure that they have access to their status owner. And if the status is an event-based one, for example, they can connect to the proper signals they want to. So if we didn't have this status yet, then we can return from this function because we add it and we're done. But what if we already had it, right? Well, then if it's a unique status and we already have it, then we can kind of return, right? For example, in the case of that power status, we have the true strength form. It cannot expire and it's not stackable either. So if that's the case, we can return because we don't have to do anything. We already have that buff. However, if it can expire and its duration stackable, then we actually need to expand the duration of that status. So what we do is we call our method, which we are yet to implement, called getStatus, and we set the duration to be plus equals the duration we want to apply from this new status. Then we can return from the function because we expanded it. And for stackable statuses, we kind of do the same, but not with duration, but with the stacks, right? And that's it. We handled all the different edge cases we can have for adding new statuses. Again, we can have one if it's brand new. We can check this with hasStatus, which we are yet to implement. Then we just add it. If it's not new, but we can't stack it and it cannot expire, then we can return from the function because we don't have to do anything. But if it can expire and stacks based on duration, then we need to extend the duration. And finally, if it's stackable and it stacks based on intensity, then we can just sort of add to those stacks, right? So that's one of those big functions we needed to implement here. We can see how this hasStatus and getStatus functions are much easier. So hasStatus receives an ID of a status and returns a Boolean based on whether we have that status or don't. So what we do is we take all the StatusUI children and iterate through them. And if one of those StatusUIs has a status which is ID is equal to the one we're looking for, we can return true from the function. But if we looped through all the children and we didn't return yet, then we can return false because then the status is not present. GetStatus will kind of do the same thing, but instead of returning a Boolean, it returns that status resource itself. So what we do is the same thing basically. We iterate through all the StatusUI children, check for ID matching, and if it matches, we can return that StatusUI child's status export variable. And if we don't have a match, then we can return null, which indicates that the status cannot be found anywhere. We'll also have a utility function called getAllStatuses, which sort of extracts an array of statuses from all the StatusUI children. And it's pretty similar to the getStatus method, except we don't need any data from the outside world. We just need to iterate through all of them, append them to an array, and return that array from the function. And finally, the last thing we need to do is that callback function we wanted to connect when a status is applied, right? So when a status effect is applied, what we need to do is one thing for now, basically. If that status can expire, then we want to subtract 1 from the duration of that effect to make sure that it, after a while, after X amount of turns, it expires. Okay, so for now, that's it. We can save this with Control S. We can sort of mull over this code we created here. And it would be nice to actually test it somehow, right? And if everything's working fine with this addStatus function, we can sort of test how it behaves. So what I'll do is I'll override the ready function here and load one of the statuses we have, for example, this exposed. And after 2 seconds, call this addStatus method we have. After 2 seconds, call it again. And then we can apply it twice to see what happens. Because if we apply it, then remember, this is connected to our callback method here. And it means that it should expire, right? In the case of this one. So let's see if it works or not. And we can run this by clicking on this button or pressing F6. And you can see that after 2 seconds, we have 1. And then something weird happens, right? We also get an error message, like what's going on here? The whole testing code should be like waiting 2 seconds at each different time, right? Yet still somehow it disappears and the whole thing looks really weird. So let's run this again. You might be able to see that for 1 second it goes up to 2. In this case it didn't. Okay. But we have this error message that we try to apply status on base null. Okay, so what's happening here? Well, it's a silly mistake I accidentally did, but felt like it might be a good lesson not editing it out from the video. So if we go back to the StatusUI script we just did earlier, you can see that I actually have some testing code here. And what we usually do is when we tested the thing and we made sure that it works like it's supposed to, we usually get rid of these testing code, right? But this time I didn't. So what happens is this waits exactly for 2 seconds too and decreases the duration by 1. So no matter what I tried to do with the StatusHandler, this was left there by mistake. So from the StatusUI code, if we delete this test we had earlier, and go back to the StatusHandler, this like sequence of events should occur now. So let's see again if we run the scene. Then it goes to 1. After 2 seconds, it goes to 2. Then we apply it, goes to 1. Apply it again, it goes to 0 and gets deleted. Exactly what we wanted to see, right? Because we add it twice. And the second time we add it, we actually want to increase the duration instead of seeing another expose next to it. So this one works, and we can test it with the other ones. So we can use muscle.tres as well. See how it works. We'll add one muscle with 2, then another 2 with 4. And no matter we call this apply function, it won't decrease, right? Why? Because we only want to decrease this number when it's actually a duration-based one, right? So applying the muscle, which is the strength equivalent of Spire, we don't want to actually decrease it, right? So that works perfectly fine. And in the case of true strength form, we should see no number at all. So after 2 seconds, it appears, no number visible. And when we try to edit twice, nothing really happens because this is a unique status, right? It cannot expire and it cannot stack either. So nothing really happens. In terms of the status handler, it remains visible and the labels won't show and won't change either. Perfect. So everything's working fine now, and this time let's not make the same mistake, right? When we made sure that everything works as intended, we can actually get rid of this test code. So far so good, but we still have one more thing left to do, and that is actually applying the status effects we need when we need them by type. What do I mean by that? If you remember from the architecture video, the whole flow of the battle logic will be a bit more polluted with introducing status effects because there are different places in time when they can get applied, right? So we have start of turn statuses, end of turn statuses, and also event-based statuses. They all have their different sort of slot when we need to apply them. So let's do that application logic next. And to do this, we need one more signal called statuses applied, which we will emit when a certain kind of status effect or status effects, if they have multiple, will be applied. So for example, if I have 2 statuses which should be applied at the start of the turn, when I applied those 2 start of turn kind of statuses, this signal will be emitted. And also we can provide a constant which is given in seconds to have this interval, this pause between applying the status effects. So we can apply one, then wait 0.25 seconds, then apply the next one, and so on. And with that signal and constant declared, we also need a new method which we'll call apply statuses by type. And we actually need to pass in one of the enum values from status.type, which can be again start of turn, end of turn, or event based. Right. So if it's an event-based status effect, then we actually don't need to do anything in this function. Why? Well, because those kind of statuses, for example, if we want to do something when the hand is drawn or when an enemy died, those will be connected to the event bus, right? So they can do their thing when that specific event occurs. So the status handler itself doesn't really need to deal with those special kind of events. However, if it's start of turn or end of turn based, then we actually need to handle them one by one. So what we do is we call that getAllStatuses method, which we provided down below, and take that array it returns, that array of statuses, and filter them based on their type. So we'll build up a queue with only those types which we are concerned about, which in this case can either be start of turn or end of turn. And then when we have that queue, we can sort of do a safety check to make sure that we actually do have any status effects, right? Because if that queue is empty, we can return from the function, but before that we need to emit the status applied signal to make sure that the flow of the battle can continue, right? So we need to avoid locking inside that state where we kind of want to wait for the status effects to be applied, but we don't have anything to apply, so it never occurs and the game would froze. To avoid this, we check if that queue is actually empty or not. And if it is empty, then we just emit the signal sort of prematurely and return from the function. But if it's not empty, we can use a tween or we can use timers or something like that. As you know by now, I much prefer using tweens. So I created a tween, looped through all the statuses in the status queue and apply them one by one, and made sure that we wait for that status apply interval constant between the different calls. So we have that little pause between the status effects. And then when the tween is finished, it means that all the status effects were applied. So inside an anonymous function, we can emit that same status applied signal, which we emitted when the queue was empty. And that's all we really need. So this is the function which will be used by the enemy handler and the player handler to sort of orchestrate the new logic, the new flow we have for the battle. And that's the status handler done. So we can save this with Control S and hook this up with the enemy and the player. So let's start with the enemy first. Let's go back to 2D view, press Ctrl Shift O and search for enemy.tscn. If we open up the scene, we can see I have our crap here. We can zoom in, right? Select the enemy, the root node, and click on Instantiate Child Scene or press Ctrl Shift A and search for StatusHandler.tscn. You can add this, and you can see that it's empty, but we can move it around however we like. I don't know, maybe something like this, but we can test this in the game later on to see how it looks like. Right, let's press Q, or we can even test it now if you want to. You just need to instantiate some StatusUI children, not StatsUI, but StatusUI under it. If you duplicate a couple of those, and just like we did before, change the custom minimum size, something like that. Yeah, this is how it would look like. And if you like it, it can stay like this. If you don't, you can move it around, maybe something like this, right? And again, when you're pleased with the look, you can delete these nodes. And one more thing we need to do, I go back to select mode by pressing Q, and I can also reset the layout because I don't really like this long line. Clicking on this button. We also need to assign the status owner. Let's not forget that. So when we actually apply statuses, we have that information of our owner, right? For example, if a status effect inflicts damage, then if we have this reference to the owner, we can call that take damage method. So click on the assign and select the enemy, the root node, as the status owner, like so. And in terms of the scene editing, that's all we need to do, but we also need to make some changes in the code. So let's click on the enemy script and see what we need to change here. So there's not much to do here. One thing we need is we need an already variable reference to the status handler node, like so. And we also have one more thing to take care of, but this is sort of preventing a big error in the future. And let me tell you what I'm talking about. So if you go to the take damage method in the enemy script, you can see that we have something like this. We take the damage, the animation plays, and so on. And if after the animation played, if the health is less than or equal to 0, then we queue free the enemy. See, there's a problem with that when we introduce statuses. Why? Let's think about this for a second. Before we had status effects and relics and anything else, then the only way for the enemy to take damage was from a player card, right? During the player's turn. So it didn't really matter if we deleted the enemy or not, because by the time we press the enter button, if we killed an enemy during our turn, it caused no problems. However, you might see that when we introduce status effects, for example, they can kill the enemies during their turn, and that's a problem. It's not enough anymore to just delete the enemy whenever the health is 0 or below 0, because that could result in a locking state when we are still waiting for that enemy to emit whatever signal we need for the enemy handler, for example, applying all the status effects, right? We keep waiting for that signal even though the enemy is already dead. We actually need to introduce a new signal and change up the behavior of that enemy handler a bit to make sure that all the remaining enemies can keep doing their turn when an enemy dies via a status effect or a relic later on. I hope that makes sense. So let's, before actually editing this, let's create a new event in the event bus. So let's press Ctrl+O and search for events.gd, and we have something called enemy related events, and here we can create a new signal, and we can call this something like enemy died, and we can actually pass the reference of that enemy if for whatever reason we need it, right? So we can save this with Ctrl+S, and going back to the enemy script, before we actually queue free the enemy, we can also emit that signal that this enemy is died already, right? Pass on ourselves as a parameter. Again, this is a preemptive measure to make sure that the game won't break when an enemy dies during applying a status effect. And later on, the same logic applies to relics as well, so we can sort of do this once and make sure it works properly, right? So that's all that it takes to hook this up with the enemy. So let's save this with Ctrl+S. And you might think that this hookup was way too easy, and you're kind of right, because we hooked this up here. We have the already variable reference. We also changed this signal emission, but the elephant in the room basically is the enemy handler, not the enemy, right? Because we need to redo the whole turn logic. So let's start with that. Press Ctrl+O and search for EnemyHandler.gd. And let's see what we need to change here one by one. And before we do that, actually just revisit what we already have, right? So we have our setup enemies, which is called once when we start a battle, and that's perfectly fine. We have our ready callback with one connected signal when an enemy action is completed. We also have the start turn, where we ask the first enemy to do their turn. And when an enemy action is completed, then we check if the enemy who completed their action is the last one, then we emit the turn ended signal. Otherwise, we take the next enemy and they do their turn as well. And we kind of have to sack all of this, basically. And we change almost every method here, so bear with me. And basically we can no longer do tricks like this to track which enemy needs to perform their turn, because it can happen that an enemy dies during their turn thanks to the status effects. So what we can do instead is we can sort of introduce a new variable called acting enemies, which will be an array. So we can keep track of all the enemies who need to do their turn, right? And if for whatever reason an enemy dies during their turn, then we can just remove them from this array, and we don't have an issue with recognizing when the turn has to end, because if that array becomes empty for whatever reason, either because the enemy finished their action or because they died during their turn, it doesn't really matter. When this array is empty, it means that the enemy team has finished their turn, right? So we actually need to populate this array at the start of each turn and make sure to delete enemies from them in two cases, either when they are dead or when they finished their actions. So first of all, we have our new signal for when an enemy dies, and the enemy handler definitely needs to connect to that. So what we do is we, in the ready callback, say that we connect to that enemy died signal with our own callback function, which we are yet to implement. So we have two changes so far: this new array and a new callback method connected to the enemy died signal. So far, so good. Another thing we need to do is in the setup enemies function, actually, when we start sort of one by one spawning the enemies we need. And here we need to do one thing. For the new, this is a pretty long line of code. So for the new enemy child, we grab a reference to the status handler, and inside that status handler, we grab a reference to the statuses applied signal. If you remember, this is emitted when one specific type of statuses are all applied to that enemy, right? And we'll connect that to a new callback method we need to implement called onEnemyStatusesApplied, which will have one parameter for the type of statuses that were applied. But to make this more useful to us, we also bind a second parameter, which is a reference to that enemy. And you'll see in a second why this becomes useful to us. Okay, so we made a new connection. We have two errors because we have two callback functions we need to implement next. But before we do that, we can leave reset enemy actions, it's fine, but the start of the turn, that's not gonna do anymore either. So what we do instead at the beginning of each turn is we clear this acting enemies array, iterate through all the current children the enemy handler still has, and append them one by one to the acting enemies array. And when we're finished with that, we call this start next enemy turn method, which we are yet to implement. Okay, so we have 3 methods we need to implement, right? This start next enemy turn and 2 callback functions, one for on enemy statuses applied and one for on enemy died. Right, so let's see how we can implement those. And we'll start with the latest one, the start next enemy turn. And this one will be pretty simple. First of all, we'll check if the array is empty, right? Because that means that there are no more enemies who need to act during this turn, either because they're dead or because they finished doing whatever they wanted to do. So if that's the case, we can emit the enemy turn ended signal and return from this function. But if it's not empty, we'll grab the first one from the array, grab their status handler, and apply their statuses by type, right? And we pass the start of turn type of status as a parameter. Why do we need to do this? Let's refer back to the architecture overview we had. If you remember, the enemy turns no longer start by executing their actions, but before they do that, we have to apply start of turn statuses. When they are finished with that, then they do their thing, and then we also need to apply the end of turn statuses later on, right? So this is how we can start the current enemy's turn. We need to check if we do have a current enemy, first of all. And if we do, then what we can do is we can apply their start of turn statuses, right? But actually, when those start of turn statuses are applied to that enemy, then they need to do their action. So this is why we connected this signal here, so we can be notified when an enemy applied a certain type of status to themselves. So now we need that callback function. And with that callback function, we have 2 parameters. One comes from the signal, and we also have access to the enemy reference because we bound it when we spawned them in the setup enemies method. Pretty cool, because now we have access to the enemy itself. And what we can do is we can use a match keyword to provide this switch or this if logic here, because it really matters what kind of statuses were applied to that enemy. If it was a start of turn kind of status, then we need the enemy to actually do their turn, right? To perform the action they opted to do. But if it was an end of turn status, then it means that enemy is basically finished with their turn. So what we do in this case is we erase that enemy from the acting enemies array, and we call that start next enemy turn to make sure that the next one can start applying their start of turn statuses. Hopefully that makes sense. And we are still missing another kind of callback function when an enemy dies. So what do we do when an enemy dies? Let's see. So when an enemy dies, we'll actually have to check if it's the enemy's turn or the player's turn, right? Because if it's the player's turn, we don't really care if the enemy died or not, because nothing will happen until the player presses the end turn button, right? So it's pretty easy to check this. We can see if the acting enemy array is not empty, basically. And if it's not empty, it means that it's the enemy's turn, because there are enemies who need to do stuff, right? Either way, it doesn't really matter whose turn it is. We can still erase this one enemy when it dies from the acting enemies array, but we still need to check if it's an enemy turn, because if it is, then we can say that, okay, this enemy died during their turn, but there can still be an enemy left who needs to perform whatever it is they need to perform. So we call this start next enemy turn method again. And this makes sure that if we do have an acting enemy, it can start their turn by applying the start of turn status effects, then doing their turn, and so on. So with this method here, we prevent that locking state when an enemy dies from a status effect during their turn. Pretty cool. And there's one last thing we need to do, and it's actually this callback method, which we already had. So this one used to be responsible for sort of cycling through all the enemies, right? When the action were completed, we could move on to the next one, because that's how it used to work. But let's think about this for a second. In the new system, according to our architecture overview, what is it that we want to do when an enemy performed their turn, their action? Well, it's one thing really. So we can delete this whole thing, and instead of this whole complicated logic, there's really one thing we need to do when an enemy action was completed, and it's actually moving on to the end of turn kind of statuses and apply those, right? And now we have our logic in place. Let me walk you through this. So when an enemy starts their turn, this is the method to be called, right? We grab the current acting enemy and apply the start of turn statuses. So far, so good. When all of those were applied, two things can happen, right? Either there will be this statuses applied signal emitted. In this case, we go to this callback function, right? And since we started this turn just now, it will be a start of turn kind of status applied. If that's the case, the next step for this enemy is to do their turn. But another thing that could have happened is that they died during their turn. And if that happened, we delete that enemy from the acting enemies. And if it's still their turn, then we call the same method and start the whole thing over again for the next enemy, right? Grab the first one, apply the start of turn effects. When those are finished, this will be called and that enemy can do their turn. And if they didn't die and finish the action they wanted to take, then this callback function will be called. And if that happens, then the final thing we need to do for each enemy is to apply the end of turn statuses, right? And when all of those end of turn statuses were applied, then the same status applied callback will be called. But this time, because we have the type available, this part of the mesh statement will execute, right? And when the end of turn statuses were applied, if the enemy isn't already dead, we can erase it from the acting enemies because it finished its thing, and we can move on to the next one. Hopefully this makes sense, especially with the architecture overview we discussed at the beginning of the video. So that's all we need to do for the enemy handler, and we can save this with Ctrl S. And before we test this with like actual statuses, it might be reasonable to test the whole game to see if we messed up anything. Because in theory, even though we don't have statuses yet, the game should work just as well as it did before. So let's run the game with F5 or pressing the play button. And if we start a new run, we should be able to do all the things we did before. So if I play a card, yeah, Crab loses their HP. You can see that there's no locking state and they perform their actions just fine. Let's block this. Right, so it seems like we didn't break anything, which is always a good sign. But it might be worth testing in a battle when there are multiple enemies to make sure that everything works fine. And you can see that the system is still intact. They perform their actions one after another. Attacking us still works. You can see that the whole thing is still working just fine. So that's a really good sign because it means that we haven't broken any existing logic. We have the same functionality we had before, but we can also start using statuses now. So what we'll do next is we start doing some logic instead of the placeholder status cards to see our statuses in action. So we can test this with all of the existing cards we have, and one of them is called the Big Slam. So let's open it up with Ctrl-Alt-O and search for bigslam.gd. And you can see that we have this print message here saying that this will also apply a status effect later on, right? So how do we do this? We can get rid of this print message. And if you remember, we have this targets array, which is an array of nodes we can have as potential targets. So we could do something like loading the status resource here and apply it one by one, providing the safety check that the target needs to be an enemy in this case or something like that. But that solution is not really the best, considering that if we were to add a bunch of new content, we might want to avoid doing the same thing over and over again, even inside that little card script. And that's what we have effects for, right? Because we have that damage effect, which is reusable as many times as we want it to, and we can sort of just configure it and make sure that it executes its thing. And I think probably the best way to go about this is to create an effect for applying statuses as well. So it will be reusable and much easier for us to do. So let's create a new status effect. So In the file system, though, we have our effects folder, and we can create a new one by right-clicking on it, creating a new script, and we can call this status_effect. And we have a template for this, if you remember. So we can use the effect template to make sure that we don't have to type in everything. And that's all we really need to do. We can click on create and double click on our status effect.gd. And this one will be pretty easy. We can rename this to status effect. And we actually do need a member variable here, and we can call that status, which will be a status resource. And for the execute method, instead of printing those two debug statements, we can do something like this. So we loop through all the targets in the targets array, which are nodes. And if that target for whatever reason is null, then we can continue. But if that target is an enemy or is a player, then we know for sure that they have a status handler because we made sure that we attach the status handler to them. I mean, not the player yet, but we'll do it in a sec. And we can do something like target.statusHandler.addStatus, right? And this is the part which will be a bit tedious to redo over and over and over again for each card where we want to apply a status effect. Instead, we can just create a new status effect every time, set this property and call the execute method basically, and we're good to go. So we can save this with Control S. And now if we go back to that bigslam.gd, we can actually create the logic for applying those status effects. And the first thing we do is we create a constant called exposed status, so we can preload that resource we want to apply, which is the exposed status in this case. Then we also need two member variables. We can use one for the base damage of the attack and one for the duration of that exposed status we want to apply. And then after applying the damage effect, we can create a new status effect, duplicate our base resource for that exposed status, set the new resource's duration property to the one we have up there. And for the status effect, then we can set the status property to the new one and execute it to make sure that it gets added to that enemy target. And one thing we can also change is instead of having that damage amount of 10, like so, we can change this to base damage. So it uses the member variable, and we can easily tweak these when we want to design the game, so we don't have to touch the code. Right? Cool. So if we save this, then we can actually test how it looks like in game. So what we need to do is to run the game, start a new run, go into a fight, and hope to draw our big slam card next turn. I guess I'm unlucky today, as it's still in my draw pile. We can play this, right? Oh, what happens? We have an error message. This is a weird one. So it says invalid type in function initialize status. The object derived class is not a subclass previously freed. What the hell is going on here, right? And something happens when we actually want to add the status effect. And this initialize status is not called, or something weird happens here. So if you take a look at this, this happens when we want to add the status, right? It's a new status, so we're in this piece of code. So far, so good. We actually added the new StatusUI to the scene, connected the signal as well, and we want to call this initialize status, and we pass in the status owner, which in this case was the bet, right? We want to apply this to the bet. And if you take a look at the variables we have here, it says that the status owner is null. This is super weird, right? Because if we open up the enemy scene and click on the status handler, we made sure that it's set to that enemy, right? We have that connection set between them. And despite that it's set, we still have that weird issue. So let me show you what I figured out when I was doing the code for this video. If we run the game again and go into a fight, we can check the remote scene tree, right? What's going on here? If we expand the run, we can expand the current view. We have our battle scene here. And under the enemy handler, we have an enemy scene, right? And this would be the crab. And the crab indeed has a status handler. And the status owner property is, for whatever reason, I couldn't figure it out really, it's empty. I don't know why we set it in the scene, we instantiate the scene. I don't think it should be empty. This might be, I think, an engine bug, but if you know why this happens, let me know in the comments below. However, it's a pretty easy fix. I don't know why it didn't set it, but we just need to go back to the enemy script. And in the enemy script, in the ready callback, do this by code. Set the status handler's status owner property to ourselves. It essentially does the same thing like we did in the editor, but for whatever reason, doing it this way seems to work. So if we press Ctrl S and run the game again, I should be able to use that. Oh, perfect. And we have 2 bets. See, I draw that card. Make sure to target one of those bets, and it indeed works. So really cool. We have those 2 exposed stacks on that enemy, and when it's their turn, it gets decreased to 1. It still has it. And if I kill the other one, you'll see that when it expires, you no longer see that. And I could apply it again, but if it kills the enemy, you can see that I'm victorious and the battle is over. Perfect. So this is how we can actually use cards to apply effects, and it works pretty well. One thing we need to do though is that expose status to actually do something, right? Because even though we apply it in every turn, nothing really happens when we apply it. So let's see how we can change this. Okay, so the problem is right now, if we take a look at all of our statuses, they share the same script, status.gd, which is sort of the baseline, right? In this status.gd, we have this apply status method, which does nothing but emits the signal. So instead, what we want to do is similar to what we did with cards and effects. We want to override that baseline behavior and actually implement the logic that's needed to be implemented based on that status. So again, we can do something like creating a new script, make sure that it extends from the status class, and we do it by hand. But this is where we want to use a script template as well to make sure that we don't mess up the method names, right? Because when we extend and create a new status, we have to have these 2 methods, the initialize status and the apply status. And to make sure that we don't have to remember this, or it's more error prone and even saves us some time, we can create a script template, just like we did for enemy actions, effects, and cards, right? So we can create a new one for statuses as well by right-clicking on this node folder and creating a new script. And we'll call this status template.gd, and we can make sure that it's actually empty by default, like so. Click on create and double click to open this up in the editor. And instead of extending the node class, we can do something like this. Let's not forget that we need metadata. So when we actually select the template, we have to know what's going on. We'll have a class name. We'll make sure that all of those will extend from the status class. And just like we did before, we have a member variable as an example, and we provide the 2 methods we need with the proper signature, right? We have the initialize status, the apply status, to sort of indicate that when you're finished with your thing, you always need to emit that status applied signal. So the appropriate handler, the enemy handler or the player handler knows that it can move on to the next one, right? So that's all we need for the template. We can save this with Ctrl S. And if we go back to the file system, we can actually create the script for the statuses much easier now. So let's right click on the statuses folder, create a new script, and we'll call this exposed.gd. And instead of the empty template, we can use the brand new status template we have here. And you can see that the metadata appears as well. And if you press create and open up exposed.gd, we have this template we can rely on when we create a new status effect. So how do we modify this baseline status template we have? First of all, we can change the class name to exposed status. Then we can also change this member variable to a constant called modifier, which will be the % modifier we use to indicate how much more damage that target will take. And since we don't really want to do anything when we initialize this status, because it's not an event-based one, we can delete this. So we don't need to override that one, but this one we definitely need to. So what we do instead of those print statements is we'll replace them with a new print statement, because this is still more like a placeholder version of that status, and I'll explain why in a second. So we'll just print out that this target should take this much % more damage based on the modifier and the name of the target. And for now, to make it pretty simple and easy to use, we just say that exposed status means taking 12 damage or whatever. This is pretty useful, so we can test if the logic we created for the enemy handler works or not, right? Because we said that in theory, when they die during their turn, the whole logic would still work. We would move on to the next enemy and everything would be perfectly fine. So we can test this. So why don't we implement the taking this much more damage yet? Well, because as I was thinking about this system, I wanted to make it as flexible as possible because there can be relics which kind of do the same thing, right? Add more damage to you or make the enemies take more damage or whatever. And if that's the case, I thought that it might be useful to implement this in a way that it's independent from the status system. So what we'll do is we'll have a modifier system in the next videos. All that this status is going to do in the future, instead of this damage effect, it will add a new modifier to that enemy to make sure that it takes more damage from attacks. So this modifier system makes the whole thing really robust and we can reuse it later with relics. And this is why this is just a placeholder thing, but we can still test if the whole applying a status, emitting the signal and all of those kind of things work, right? For now, we just use what we have and we'll build up on it in the future. So this is perfectly fine for the exposed for now. We can save this with Control S. And if we go back to the file system, let's not forget to actually assign this to the exposed resource, right? Because if I double click on it, you can see that this is still status.gd, the script we have, I mean. So we can replace this by dragging and dropping expose.gd here. And again, the same kind of thing happens, that the icon resets for whatever reason. So we can again just load it back from the art folder. This should be this X right here. Cool. So if we save this, we can run the game to see if it works or not, creating a new run, going to a new fight. Okay, so we do have the card. It should do 4 damage first. And it does, and it has this exposed status right here. But if I end my turn, then the duration will decrease by 1. And the status also applies at the start of the turn, which means that the duration will decrease by 1 and they will take 12 damage. Awesome. So it actually works. So with this done, let's not forget that we need to hook up all the new systems with the player and the player handler as well. So let's go back to 2D view and press Ctrl-Shift-O and search for player.tscn. Here, hooking it up is actually pretty similar to what we did with the enemy scene. So let's select the root node again, click on the Instantiate Child Scene button or press Ctrl-Shift-A and search for StatusHandler.tscn. And once we add it, you can see that it's at 0, 0. So if we go into move mode by pressing W, we can position it however we like to. Something like this. Again, if we want to test it, we can instantiate a couple status UIs under it. I won't do it this time, but you can go ahead and do it just to make sure that it's something you like. And let's not forget to assign the status owner, this export variable, to the player in this case, even though just like we did with the enemy, we have to override the ready callback again because of that unexpected behavior we've just seen. So that's all there is to it, to setting it up in the scene. Let's save this with Control S and let's modify the script as well to make sure that we accommodate those changes. So click on the script icon and see what we need to change here. So here in the script, we don't need to change that much stuff. One of those changes is actually grabbing an already referenced variable to the status handler so we can access it whenever we can access the player as well. And to make sure that this bug doesn't occur again, just to make sure, even though we set the export variable, in the ready callback, we set the status handler status owner to a reference of ourselves, meaning the player itself. And you might ask that, hey Adam, we did a new signal and all that stuff for the take damage method with the enemies, and we made quite a big fuss about it. So what about the player? Well, if we go ahead and take a look at the take damage method. In this case, we actually don't need to change anything because we already handled that player died signal emission previously. Because if you think about it, there is only one player character And if the HP of that player character drops below 0, whenever that happens, it means game over, right? So we don't really need to worry about any of the stuff we discussed with the enemies because there are multiple of them. They need to manage their turn and so on. In this case, we already handled that anyways with that player died signal, but it's not a problem either way because the player dying always means that it's game over, right? So all we need is these changes. Grabbing an onReady variable reference and overriding the ready function. So with this ready, we can save this with Control S, and hooking up the player with the new status handler is basically done. But unfortunately, we can't get away this easily, right? Because even though the player itself, this more like visual representation, has the status handler attached to it, there's still a lot of turn management logic and battle flow logic, which is applied at the player handler node, right? So that's where all the meaningful changes will occur, because again, this kind of disrupts the flow, or we need to make a change to the battle flow, just like we did with the enemies. So let's press Ctrl+O and search for PlayerHandler.gd. And this will be a bit easier compared to the enemies because we don't have to make that drastic changes to it. So let's scroll all the way up to the top of the script. And the first thing we'll actually need on top of all the stuff we already have is an export variable reference to the player. Why? Because we need to access the status handler, which is attached to the player, right? So we need a reference to the player itself. Then we need to examine all the methods and the logic and make some changes here and there to accommodate this new status handler business we have. And the first one will be the start battle method. This is sort of like an initializer, right? So we apply the new character stats, we fill the draw pile, we shuffle the deck, all that stuff, and start our first turn. And before we start the first turn, we actually need to connect to that status applied signal for the player status handler, just like we did with the enemies when we spawned them, right? So what we do is we connect that onStatusIs applied callback method to the player's status handler's StatusIs applied signal. And mind you that we have an error here because we are yet to implement that method. So far, so good. The next thing we need to do is actually starting the turn. Because right now, when we start the turn, we reset our block, reset our mana, and draw as much cards as we can, right? However, according to the new battle flow logic, which we'll have, this is not what we want at all, because before drawing any cards, we actually want to apply all the statuses, which are start of turn type, right? So we can replace this line with player.statusHandler.apply statuses by type, and we can apply all the start of turn statuses the player currently has. In a similar fashion, when we end the turn, we disable the hand, which is perfectly fine, but we no longer immediately discard all the cards, right? Instead of discarding the cards, when we click on the end turn button, we disable the hand, that's fine, but then we kind of do the same like we did with the start turn, and say that the player's status handler should apply these statuses by type, and this time we want all the end of turn statuses to apply. Okay, but now we actually can't play the game, right? Because we never draw our hand and we never discard all the remaining cards. And this is where this onStatusIs applied callback function, which we are yet to implement, comes into play. So if we scroll all the way down, we don't need to change anything else really, but here at the bottom we need to implement a new callback function, and we call this onStatusIs applied. And here we know which kind of statuses we applied when the signal is emitted, and we have two distinctive cases, right? If it was a start of turn kind of status, then we need to draw the cards. And if it was an end of turn status, then we need to discard all the cards which are still in our hand. With these changes, we've implemented everything we needed to, but let me just real quick walk over all these changes again, see how the logic flows during one turn. So first of all, let's save this with Control S. And if we go back to start turn, this is where we always begin, right? So whenever a whole cycle or loop of game logic goes through, we end up with the player start turn method being called first. And what we do is we reset the block, reset the mana, and say that, okay, we need to apply all the start of turn statuses to the player character. Cool. Whenever we finish with that, let's not forget that we connected our callback method to the status handler statuses applied signal. And this will be only emitted when all statuses of one particular type were applied. So we apply all the start of turn statuses. When that's done, our callback method, this one will be called, right? And what happens is if it was a start of turn, which was in this case, then we draw all the cards. And when all the cards are drawn, we can start playing our turn just like we did before. So far, so good. We play some cards and hit the end turn button. When we press the end turn button, this end turn method will be called. And what we do is we immediately disable the hand of the player and then say that, okay, before we actually discard the whole hand and move on to the enemies, we want to apply all the statuses by type, and this time we use the end of turn statuses, right? Okay, we apply all of those, that's finished, and then the same callback method will be called, but this time the match statement will match to this end of turn, right? And when that's done with, then we can start discarding all the remaining cards in our hand. Then the battle will tell the enemy handler that the enemies are ready to start their turn. So with these changes, we actually implemented the whole new game loop, that new flow logic in the battle, which we discussed in the architecture overview. It will be nice to test this, right? But one thing you shouldn't forget is if we go all the way up here, we actually introduced a new export variable to the player handler, so we need to set this, right? But where do we need to set this? Where do we have a player handler node? In the battle scene, right? So let's go back to 2D view, press Ctrl-Shift-O to quick open a scene and search for battle.tscn. And indeed, if you click on the player handler node here, you'll see that we have a new export variable for the player, which is yet to be assigned. So if you click on this and select the player, let's not forget to save that battle scene with Ctrl-S. And now we can test this and everything should still work the same. So let's go ahead and play the game, start a battle. And you can see that sort of seems like I immediately draw my cards, right? But what happens under the hood is we try to apply all the start of turn effects, but we have none. So the signal is almost immediately emitted. Then we draw our cards. We can play our turn here. If I end my turn, you can see again, it's like I immediately discard all my cards. But in reality, we revamped this whole logic, right? So whenever we introduce new statuses, they will work. But it's kind of hard to test those, right? Because we only have the exposed, and while we could add it to the player, why don't we do the muscle and the true strength form scripts so we can test if everything's working or not. So that's what we'll do next. So to test the player handler side a bit better, we might as well do some placeholder code for the muscle and the true strength form. So let's start with the muscle by right-clicking on the statuses folder and creating a new script, which we'll call muscle.gd. And this will use the node status template, so it's easier to make the code, right? Let's press create and double click on muscle.gd. So this is a placeholder code because this muscle or strength sort of status effect will amplify our damage, right? And to do so, we'll need the modifier system, which we haven't got yet. So again, this is just placeholder code, but it's good enough to test our status effect system. So let's rename the class name muscle status. And this time we won't be using a member variable. And just to test if it works or not, we can actually use that initialize status method and say that we connect the status changed signal to a callback method we'll provide. And instead of this apply status where we actually do something, we can sort of override this later. And for now, we'll just say that this onStatus change will print out the debug message saying that we should have plus damage equal to the current amount of stacks we have, right? So this will be perfect for testing purposes. And we can save this with Ctrl-S. And before moving on to true strength form, let's not forget that we need to assign this script to the resource itself. So let's double click on muscle.tres. You can see that it has this like base status script attached to it, but we just provided our own. So drag and drop this over and you can see this annoying little thing where the icon disappears when I do that, but we can just sort of reassign it. Let's save this with Ctrl-S as well. And let's do true strength form while we'll edit. So again, right click the statuses folder, create a new script. This one will be true strength form.gd. Again, make sure we have the node status template available. We can double click this and let's see what we do here. So first of all, let's rename this from my awesome status to true strength status or something. And instead of that member variable, we actually need a constant so we can add 2 muscle stacks every time a new turn starts, right? And here we don't need to initialize anything. We just need the apply status callback. And here what we do, we can leave in a debug message just to see what's going on. And it's pretty easy. We have our status effect we can use, right? So we'll create a new status effect. Then we'll create a new muscle from the preloaded muscle status resource by duplicating it, change the amount of stacks to whatever we like, and then set the status effects status to that new resource we created and execute it. And then when it's done, let's not forget to emit this status applied signal. Right. One thing we can also do is instead of using 2 here, we can create a member variable, right? So let's say for stacks per turn and make sure that it equals to 2. And again, we can change this to stacks per turn. And this way, when we're actually at the balancing and designing stage of the game, we don't have to touch the code. We just need to tweak those variables, right? It makes it a bit easier. Okay, you can even make this an export variable if you wanted to. Okay, so let's save this with Control S. And one last thing we need to do is to, again, assign this script to the resource because they are not connected to each other by default, right? We make them separately. So let's not forget to assign this here. Again, the icon will disappear. But you know the drill by now. You just need to reassign it. So if you were doing this to actually create new content for the game, I recommend changing up this method and do it in the opposite way, right? So first create the script, and then when you create a resource before filling any of these information in, then you can assign the script so you don't have to like redo the icon over and over again. Right. So with that said and done, we should be able to test this. So if we run the game and start a new run, we have our exposed status, which still applies. And if I end my turn here, maybe I can do some more damage. And if I end my turn here, this bat dies and takes 12 damage, but the other bat still executes its action, which is perfectly cool. And then we can play this power card, which should, in theory, apply that status. But see, the problem is we didn't update the card itself. So it says that this will apply a status to our character. And even though I created the code for the status itself, I didn't modify the card, which should actually apply that. So let's quickly do this because I forgot to do it. So press Ctrl+O and search for true strength warrior true strength.gd, which is the card's code, right? And no wonder we have no status because this is just a print message. So instead of that print message, what we can do is we can create a new constant called true strength form status and load that status resource. And then instead of printing out this debug message, we can create a new status effect. Then we can duplicate this resource we have and set the status and execute it just like we did before. Here we have an error message because I use underscore targets here because it wasn't used. So we don't have any warning messages, but now we want to use it. We can delete this underscore here to make sure that they match. And if we save this with Control S, now I should be able to go into that true strength form. So if we start a battle, and now comes the fun part. So if I play this power card, you can see that the 3 mana will be used, and then I'll have this little potion icon here, right? So if I end my turn and start my next turn, I'll have 2 muscle added, right? Pretty cool. And if I were to end my turn again and block some damage, then it goes up to 4. And what I also wanted to show you, and this is why we have a debug message here, is if you take a look at the output window, you can see that the order of the statuses actually matter, right? Because I have this true strength form first, and then it applies the muscle. And you can see the order of the messages, right? It says applied true strength form, and then it says muscle status plus 4 damage. Even though I don't have the plus 4 damage because we don't have the modifier system yet, it still kind of works as expected. What happens if I play this card again? Well, nothing, right? Because I already have this form applied, and this is non-stackable and it doesn't expire. So in this case, we don't add it again. I won't get 4 muscle per turn. It still adds 2 just like it did before, which is perfect. This is what we expect from this. But we still have one minor problem. If you think about how powers work in StatusSpire, when I play it, I should no longer be able to play it again, right? It shouldn't go to my discard pile. But if I take a look at my draw pile here, it's still there. So we don't have a way to sort of get rid of these cards yet. And this is a mechanic which is called exhaust in StatusSpire. So if you play a card and it exhausts, it means that for that battle, you cannot use it again. It won't go into your discard pile. It will go to a separate pile and you cannot play it again. Mind you that this doesn't mean that it will be erased from your deck. It just means that you cannot play it again during that battle. So we want to do this exhaust mechanic last in this video, so power cards can be exhausted by default after we play them. Okay, but actually implementing exhaust this far into the project sounds pretty complicated and scary, right? What happens if we mess with all the systems we currently have? And you'll see that since we have good architecture so far, it will be a breeze to add a feature like this. So the first place we need to edit it is actually, you guessed it, card.gd. So let's press Ctrl+Alt-O and search for card.gd, which is a custom resource of ours. And we have these groups of export variables. One of them is called card attributes and one of them is called card visuals. And we can just add sort of a checkbox here saying that exhausts, and by default we can say that it's false. Okay, because most cards in the game probably wouldn't exhaust, right? Only the more powerful ones would. Honestly, that's all we need to change here. So save this with Ctrl+S. But since this is an export variable, we actually need to change some cards, right? So if we go back to the file system and we kind of tidy up this a bit, we can go under characters, warrior, and cards. And we can say that the true strength form will exhaust. So we just need to take this export variable here. And we can do the same for the big slam, which is this 2-mana attack, which applies the exposed, just to see if it works or not. And we can save this with Ctrl+S. Right. And this would work. However, in StatusSpire, all power cards are exhausted by default. And what's more is that there are some cards which allow you to sort of bring back cards from the exhaust pile, because there's a separate pile called exhaust pile. But since it would be too OP, power cards are not added to the exhaust pile, so they sort of exhaust, but they don't at the same time. And to mimic this behavior, we actually don't have to set exhaust on power cards, right? Because we have the type available. So we can handle powers differently if we want to. But for any other cards, skills or attacks, if you want it to exhaust, then you can actually tick this box. But for powers, we don't want to, because in the future, you might want to handle them differently, just like in the game. Okay, so how do we make sure that these cards can get reshuffled into our deck? Well, it's just one tiny change in the PlayerHandler script. So let's press Ctrl+Alt-O again and search for PlayerHandler.gd. And here we just want to make one change in one callback function. If you take a look at all those methods available here, we have one called onCardPlayed. So let's click on this one. And you can see what happens when we play a card, right? We say that when we play the card, that card should be added to the discard pile of the player. Well, not anymore always, right? So what we can do instead is we can do a safety check and check if the card exhausts or if the card's type is power. Then we can just return from this function immediately, meaning that that card won't be added to the discard pile. And that's it. Basically, it's 3 lines of code, and we've implemented exhausting in the game. So let's save this script and test if it works or not. I draw both of them. Let's say I use this one first. And you can see that when I release the button, the card gets played, but it doesn't appear in my discard pile, neither in my draw pile. And if we add those numbers together, it kind of adds up, right? We have 4 cards in the discard pile, 4 cards in the draw pile, and 3 in my hand, which is in total 11. But you can see that my deck still consists of 12 cards and the blue card is still there, right? So whenever I end my turn here, the bet dies, and we can wait for the power to see if that works as well. Because remember, for the power, we didn't check at the end this exhaust property, so when I play this, cool. Okay, so I played the power successfully, but my discard pile remained empty. And I have 10 cards in total, which absolutely checks out, right? No blue or gold cards here, but my deck still has it. And the effect of it is still applied during the start of each turn. Wonderful. So if I win this battle and move on to the next one, you'll see that I still have my cards in my deck. I still have 12 cards in total. I just couldn't use them in the previous fight anymore because they exhaust now. And for this project, I didn't add another button to view the exhaust pile because the screen is pretty polluted anyways. I feel like we have so many different UI elements for all the little things we need and so little space. So I decided not to do a button here, for example, where you can view all the exhausted cards or your exhaust pile. But if you want to do it, I think it's a good little challenge to see how you can extend the behavior we currently have. It would be a pretty easy addition based on the discard pile and the draw pile we implemented earlier. So if you want your players to see the cards they exhausted in the battle, I encourage you to try to implement that feature on your own. But for this video, that's it, and I'll see you in the next one. Bye bye.